I'm a full stack developer and trainer, and I have more than 8 years of experience working as a developer and trainer. Um, I've handled various projects and for various clients, and I also train various professionals working in various industries. Right. And here I am today to take you through different aspects of full stack development. Right, and hope this session will be helpful. And can we go ahead, guys? Yes, no. Right. Yeah. Right. So I'll share my screen. Diane, you able to see my screen, right?
Yes, sir.
Yeah. Thanks. Right. So this is the agenda today. So basically here, so this masterclass is about giving everyone a glimpse of what this full stack development is all about, right? So why someone has to be a full stack developer, right? So why not just be a backend or front end or a testing or an operation guy? So why he has to acquire all the aspects of development, right? Why someone has to be full stack development, and what are the things that encompasses the full stack development, right? So this so here I am planning to take you through the different such aspects, including what are the different languages, practices, frameworks, right? And the opportunities and the demand for a full stack developer, right? And I've categorized this session into four major topics. One is that we'll get to see what is full stack development basically, and then second thing, we'll see a glimpse of we'll have a walkthrough on different tools and technologies that involved in full stack development, right? So in case if you, for someone who wants to get into development and to get an edge over the other developers, right? So what is the path that you can take, right? So that is the two is all about the different such tools and technologies and paths that one can take to become a full stack developer, right? And the third thing is best practices, and finally we'll also see what are the career opportunities for a full stack developer, and the demand of full stack developer in the upcoming years, right? So we'll start with what is full stack development. um, so to understand what is full stack development, we need to understand what is the primary architecture of developing an any application, right? So when I say development, it is about developing an application, and when I say application, it encompasses all types of applications, right? So we have applications that we as a user we are we have application that we use in mobile, we have application that we use in laptops, right? I mean, we install in our machines and then we use it. um, so we have applications that we access via browser, right? So we have mobile applications, we have native applications, the application that we use to install on our machines across various machines, right? And then we have applications that we access via browser, right? For all these applications, we have a primary architecture, right? It doesn't have different architectures. It may differ when you uh, you know as we go higher and higher, but fundamentally we have a common architecture, right? And this is that architecture, right? So we have users who will be interacting with our applications, and how he interacts with the applications will be having front end, right? So front end part of the application is what we see as a user when we get to work with an application, right? see all the user interfaces, right? All these text boxes, the buttons, right? All those things that are visible in our window will be part of the user interface, right? And that is how we get to interact with the applications, right? And how basically the application works is the code that runs in its backend, right? So how the application behaves, and that is coded as part of backend, right? So basically we as a user interact with these functionalities, we make the applications to behave using its user interface, right? And then um, these applications, how it manages the data, it will use the data store, right? So primarily it involves three things: front end, back end, and the way it manages the data is by using a data store, right? So that is where it uses the databases, right? So primarily when it comes to developer, so who are all responsible for building these applications, right? So we have front end developers who will take care of front end part of the applications, meaning they will manage the development and the other aspects related to front end alone. And then we have backend developers who will only focuses on the backend functionalities. And then we have database guys who will work on the databases, who will get to manage the data stored in the databases. And this application has to be tested, and then we have testers who will get to test the applications. And then these applications that is developed has to be deployed in a platform or environment, right? It has to be deployed in multiple environments. So how will you shift our applications to these different environments, and how will you deploy this? How will you make the applications in run in different environments? And there we have operation guys who will manage it, right? So we have front end guys who will be managing the front end part of the applications, and we have back end guys who will be managing the back end part of the applications. We have database guys, we have operation guys, we have testing guys. So we have different people with different roles to manage the different aspect of the applications, right? Right. So this is the technical infrastructure. So whatever that we have discussed, that forms the technical infrastructure of a software applications, right? So the things that we discussed, um, that includes front end, back end, databases, DevOps, security. I've listed here the primary things, but this is a long list, right? But this is a primary thing that forms the technical infrastructure or the primary elements of a software application, right? Right. So like I mentioned, so there will be different guys and with different roles who will be managing the different elements of these different elements of the software infrastructure, right? But who's a full stack developer, right? You guys able to follow me? Right.
Yes.
So yeah, thanks. Right. So now we saw like we have different people with different roles to manage different aspect of the or different elements of the software infrastructure. Now when I say full stack developer, now instead of multiple persons with multiple roles, now we will be having one person who will be having knowledge across the entire infrastructure, or rather the entire all the elements that compasses the software infrastructure. Now instead of multiple people with multiple roles, we'll be having a single guy who will be managed. We will be having a single guy who will be managing all these things. Right now he will be a full stack developer, right? So why someone has to acquire all these things? Why can't I just be a front end developer and specialize in all the front end related things? And why can't I just take a back end? And why can't I just become a back end developer and specializes in all the backend related things? Why someone has to become a full stack developer, or why someone has to acquire all the knowledge of the entire infrastructure, right? So that we will come in a minute, right? So it's a full stack developer, right? So full stack developer, like I mentioned, now instead of having multiple guys for managing multiple aspects of the software applications. Now here I'll be having a guy who will be having knowledge across all these things, and he will manage us all part of the applications, and he will be a full stack developer, right? Right. So he will be doing, so I'll be having a single guy who will be who will develop and manage the front end part of the applications. He will be writing the backend functions, and if you ask him to test, he will do that. If you ask him to shift the applications to different environment, he will do that. He know all the tools and knowledge necessary to do that. If you ask him to uh, deploy it, he will be able to deploy it. He will be able to monitor it. If you ask him to ask about or take care of the security, he will be able to do that. So primarily a full stack developer will manage us all the aspect of the software software applications, right? And why someone has to be a full stack developer, like I mentioned, why someone has to be a full stack developer, right? Right. So these are the reasons. So these are the primary reasons of why someone has to become a full stack developer, right? And this will give a full stack developer edge over the other developers, right? So if there is a backend developer and I have a full stack developer, uh, why someone has to go for a full stack developer? This is the reasons, right? So full stack developer will be more versatile, more efficient, better in communication, better problem solving, and cost effective from a company perspective, employee perspective. A full stack developer will be better in all these things when compared to a normal front end or normal back end developer. Reason being, he will be versatile. Versatile in the sense he'll take up any roles. So he suits for any roles, right? From my employee perspective, from a business perspective, I want someone to be. I want to use my resource wisely, right? So I have a resource. I have a front end developer. When he is done with this current front end project, and if there is no upcoming front end projects, he needs to wait, or he needs to the company needs to replace him, right? If there is no front end projects upfront, right? But then if he is a full stack developer, he no need to wait for another front end development project. He can take up a backend role. He can take up a database role, right? So primarily he will be versatile, right? So he can fit into any role, and he can adapt to different environment, right? Right, and that is not the case with a normal front end or back end developer, right? If I take a front end developer, he will only fit into jobs related to front end, right? I can't place him in a back end role, right? Unlike how a front end developer will used to behave, right? So now, based on this, since he is versatile, he will be more efficient, right? Meaning, as a full stack developer, now you will be having all the knowledge about the entire infrastructure of the software. So you don't rely on another person's uh, for to proceed with your project, right? So you'll solve you yeah, as a full stack developer, you will be able to solve most of the problems without the help of the others, and that will be that makes him more efficient when compared to a normal front end or back end developers, right? And he'll be able to communicate better with the other teams, right? So the inter team communications will be more effective when you are having knowledge across all the like I mentioned, all the elements of the software architecture. Meaning, if you want anything from a tester, right, and if you want to communicate anything to the testing team, now what are the different parts of the testing, right? So you know about how smoke is done, smoke test is done. You know how end-to-end testing is done, system testing is done. Now, as a full stack developer, you will be having knowledge on all this testing, right? So meaning you will be able to communicate much better, and the testing team would be able to know their requirements much better from a guy who will be able to communicate much with much more clarity on these things, right? Right. So improve problem solving, and then cost effective, right? So now, like I mentioned, this is from a business perspective. Now the business owner doesn't needs to have multiple persons for managing an applications. He can have one or two full stack developer who will manage the entire applications, right? So as a full stack developer, we will always have a edge over other normal developers, right? Right. So these are the different skill set that forms the full stack development. We call it as FSD skills. For someone who wants to become a full stack developer, and this is a checklist, right? So he or she needs to learn front end languages, and followed by front end frameworks, and he has to learn back end languages, back end frameworks, databases, API design and development. API is how we make the applications to speak between them, right? And that is how we get to integrate different applications, right? Testing and deployment, managing the source code, we call it as version control, right? So different testing frameworks and responsive web design, single page application architecture, agile development methodology, microservice architecture. So these are the different things: serverless architecture, cloud infrastructure, project management, and collaborations. So this primarily, this checklist primarily forms all the skills that one required to become a full stack developer, right? So now what we are going to do in this master class is we are going to uh, get a glimpse of different things, right? Different things that involved in these FSD skills, right? So how this masterclass is going to help you out is you will now know where you have to start, right? In case if you wish to get into development, and if you want to have a edge, and if you want to be in that pool, who the business owner wants, and then this masterclass help you out in where you have to start and what are the things that you need to pick up to start the journey to become a full stack developer, right? Right. So we start with front end technologies. So these are the three front end technologies that that forms the pillar of uh, you know uh, user interface, right? So meaning this is about developing the front end, right? So there are three major pillars. One is the HTML, the other one is CSS, and the third one is JavaScript, right? So HTML, which stands for hypertext markup language, is how we get to create our content, right? It is how we organize our content. So whatever things that we are seeing in the browser, they're all HTML files primarily. When you send a request to a URL, what you get is always going to be an HTML file, right? HTML file is how we organize the content that is supposed to be published over the internet, right? Uh, so the primary thing is HTML, and followed by CSS. CSS is how you get to style your HTML content, right? So HTML is how you get to structure your content, and CSS is how you get to style your content, right? So all the colors, different alignments, right? All those stuffs are basically is of CSS, right? So HTML is how you create content, organize content. CSS is how you style your content, where you make your content more presentable, and JavaScript is how you make your content interactive, right? So whatever application that you are that we are using right now, whether it's a web-based application, or whether it is a mobile application, they are all very interactive. So you can see different elements in the application where you can interact with. So you see a button that will where you can interact by clicking it. You see different elements when you hover your mouse, or when you touch. It will show some animations, right? So all these things are primarily because of JavaScript, right? So if you want to create an engaging front end part of the application, then we need to be proficient in HTML, CSS, and JavaScript, right? So these are the three primary front end languages that one has to accompany to become a full stack developer, right? And followed by, so now we know the languages. Now what are the things that forms the user centric web development, right? So One is responsive design. So apart from, after getting to know about the languages, what type of user interface that we need to create, or what kind of skill that we need to have, right? So I know HTML, CSS, JavaScript. I know I should be able to create the user interfaces, but what kind of user interfaces that I need to create, right? So the user interface that I need to create, it should be responsive, it should be fast loading, and then it should have strong security, right? So as a full stack developer, apart from getting to know about the front end languages, it is also important uh, to have the skill of creating responsive design, to have the skill of creating, to have the skill of making a fast loading application, and to be, he should be able to have the security knowledge as well, right? Right. Right. So after front end languages, so one having the knowledge of front end languages alone would be able to solve all the user interface problems, right? But how much time and how challenging it is going to be to develop a application, right? So when I say applications, we have simple applications, right, from simple websites where we get to see the, where we just get to see the content, and there are way more complex applications, right? So there are new news, there are applications where we just watch the news like the normal websites, and there are applications that we access in our web, in our browser itself, where we can do some uh, you know uh, typing works like Word, Excels, right? And there are applications where we can watch the videos, and there are applications where we can uh, 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 get into transactions like the e-commerce sites, and there are applications where we can get into manage our bank accounts. So these applications ranges from simple applications to much more complex applications, right? Small applications to big applications, right? So with the front end languages, we will be able to develop and manage a simple applications. But when it comes to complex applications, that front end language alone would not be able to sufficient to create a more complex applications. So we'd be able to do it, but then it is going to be much more complex in developing and managing it. And that is where we also need to learn some of these frameworks as well. So these frameworks will be having a lot of inbuilt things. So we don't need to do anything from scratch. So we don't need to do all the things from scratch, right? So whatever that we require, for instance, I need a responsive button, right? For instance, I need a responsive banner, or for instance, I need a responsive header for my website, or for my web applications, or for just for any of my applications. So I don't need to start it from scratch. So what I can do, I can take help from these frameworks. So these frameworks will be having some inbuilt templates, and then inbuilt things that we can use in our applications, right? So that is going to save more of our time, and that is going to uh, you know that is going to take more, that is going to save a lot of our time, and then that will also allow us to get rid of much some of the repeated tasks that we might need to do, right? So this is a big thing in uh, a small shell. So it has a lot of things that it has a lot of problems that it can solve when you go to use a framework, right? So apart from languages, the primary front end languages, so it is important for us to get the proficiency of any of the frameworks, right? And here I have a list of frameworks that anyone that's one can pick up. It is not that we need to know all of these frameworks. So these are all uh, different frameworks, and they are their competitors themselves. So we can pick up any one of the framework, right? So HTML, CSS, JavaScript is the primary. Uh, Everyone should know it. But when it comes to framework, and it is up to us uh, what we can pick up, right? For instance, Bootstrap is widely used, and Tailwind is also equally used in recent days. And then we have Materialize, Semantic UI. So one can pick up any one or two this framework, that where it will help us to manage much more complex applications, right? right? So Bootstrap is widely used. So in case if you are interested, probably you can start with Bootstrap, and then slowly you can work with Tailwind or Materialize. So these frameworks have their own strengths and weaknesses, so we can get to explore things depending upon our project. We can try out Bootstrap. If things are not working with Bootstrap, then we can switch to Tailwind, right? So there are different projects right now going in companies itself that uses majority of these frameworks, right? Right, and like we have the so this is primarily for CSS, so this will solve your complex styling problems, and the same thing goes for the interaction as well. So how will I create complex interactions? So just with plain JavaScript, I won't be able to do all the things, right? Or it will be difficult to do all the complex things. So like I take help from CSS framework. There are also several JavaScript frameworks available that will solve a majority of the complex interactions problems, right? So there is Angular, there is something called Angular, and there is something called React, Vue, Ember, Backbone. So these are the different JavaScript frameworks that is there, right? And like I mentioned for CSS framework, and here too, depending upon our interest, we can take any one of the framework, right? So for instance, you can start with Angular, and you can become a specialized person who can work in Angular, and or you can start with React, and you can explore, you can do certain things in React, and if things are not working and if it is not interested, then you can switch to Angular or Vue, right? So it is not that we need to learn all of this framework, like I mentioned for CSS. So you can either go with Bootstrap or like I mentioned for CSS, uh, here too you can either go for Angular or React or Vue, right? So these are the different competitor JavaScript frameworks available, right? So we have to learn all the languages. We have to learn one or two CSS frameworks and one or two JavaScript frameworks, right? Or even as a beginner, even if you start with one CSS framework and then one JavaScript framework, it would be a good start, right? Right. So followed by JavaScript. So JavaScript is primarily a you know so the may the may the may the major aspect of JavaScript is that it should be easier to implement things, right? You should be things should be easy, and then things should be fast. So that is the primary objective of JavaScript. So what does this mean? To start, so initially as a beginner, if someone who is starting to use JavaScript, he will be finding it more easy and more fast compared to other programming languages. But then going forward, the same thing will become a bottleneck, right? So JavaScript primarily is a statically typed language, meaning it doesn't have the it doesn't provide type checking by default, right? Type checking in the sense, in case it won't show up all the errors, right? It will show only on the runtime, and it will be difficult for the developer to find the error and to fix it. That is the primary nature of the JavaScript. So hence JavaScript is accompanied by some of the superset languages like TypeScript and Babel, right? So on top of JavaScript, it is also important for us to know these superset JavaScript as well, like either TypeScript or Babel, right? So for instance, Angular is using TypeScript, right? So if you want to pick up Angular, then you need to know TypeScript. So there are different resources available in the online itself. So for all these things that I am introducing you, for all these sites, you have the official website itself, right? So in case if you want to learn Bootstrap, or in case if you want to learn Angular, you can go to their official site. There itself you have a uh, you know uh, uh, a primary curriculum that you can start, and then you can start to do things, right? So you don't need to rely on any other thing to start things, right? Right. So on top of JavaScript, we have TypeScript or Babel, right? So if you want to get into Angular, then you might need to learn TypeScript, or if you want to use React, you might need to use Babel, right? Right. So now these are the these are the things are about front end technologies. So we saw front end languages, CSS frameworks, JavaScript frameworks, and then we saw JavaScript compilers, right? Right, and followed by now we'll move into what are the different backend technologies that we need to acquire to become a full stack developer, right? Right, so just like the way you started with front end languages, so here too we need to pick up a language, right? So there are different languages we have to write our code, right? So we have Java, right? Of course, JavaScript is also there. So with JavaScript, we can do front end code that will get executed in the browser, right? And we can use JavaScript to write the server side backend code as well, right? And then we have Python. So these forms a different track. So we have Ruby, we have PHP, we have C Sharp, and then Go. Again, right? So we need to be proficient in any one of the languages. So we don't need to be proficient in all the language. So we need to pick up one backend language, right? So we need to pick up all the primary, languages, all the primary front end languages. One CSS framework, one JavaScript framework, one JavaScript superset or transpiler, and then when it comes to backend language, we can start from one backend language, right? So it can be it can be any one of the any one from the list that you are seeing in the screen, right? And again, this is just um, uh, you know a subset of different other programming languages, right? So we have so many other programming languages, but these are the majorly used, so we get to use any one of the backend language, right? Right. So and again, so with by just knowing the languages, we won't be able to solve all the complex tasks like we mentioned for the front end problems. And here too, we will be having a lot of complex backend problems as well, right? So if the functionality that you are going to implement is simple, uh, you can just use the primary language features to implement it and manage it. But as it goes, as the complexity goes higher and higher, right? So for a big projects, just the language features, the native language features is will not be enough for us to build and manage the uh, application, right? Again, we have so many frameworks available that we can use to manage the different constraints of our applications, right? So where we can focus, I mean, the first thing is we don't need to start from scratch, and then we don't need to manage all the things, right? Some of the we can focus on the primary objective, where the secondary objective will be managed by these frameworks, right? Right, so now what does it mean, right? So all the applications will be having two main functionality, right? So the functionality that you are going to implement, we can categorize into two. One is the primary functionality, right? And then we have secondary functionality, right? So primary functionality is what we are making the application to behave. For instance, if you are using an e-commerce site, uh, you know exploring the products, placing the order, right? Selecting the product, comparing the prices, all of these stuffs will be becoming the primary functionality, right? So as a user, if I'm using an e-commerce site, this is what I expect, right? So this will become the primary functionality, right? And all those things, I'm so as a user here, I won't be worried about how fast the application is, about how uh, you know where the application is getting stored, right? What is the line of code, right? All those steps, what are the dependency involved, right? What is the type of security that is getting implemented, right? So as a user, this will be hidden from the user things, right? Apart from the primary functionality, all the functionality that are related to managing applications, right, that will become the secondary functionalities, right? And that will be the developer's headache, right? So like these primary functionalities are important, implementing the like these primary functionalities are important, implementing these secondary functionality is also equally important, right? So we cannot get rid of the secondary functionality even though it is hidden from the user. The users who are using the applications will not directly be involved with the secondary functionality, it will be there, right? So as a user, uh, as a developer, the secondary functionality will be the difficult thing to implement, because now when I say secondary functionality, it is about managing the security, it is about managing the code, it is about managing different dependency that you are going to use in our application, right? It is going to be about how you build, it is going to be about how you test, right? All these things will form the secondary functionality, right? So these things will be managed by the frameworks, right? So we basically use the frameworks to manage the applications, to make our development process simple, right? So where the developer can focus on the primary functionality, implementing the primary functionality, right? Yeah. So if the application is simple, we will be using the native language functionality itself. But then as the application gets complex, we definitely need help from these frameworks, right? So here I have some of the frameworks listed out. So if you are Java, then you can take up Spring, and if you are you are using .NET, then you can use ASP.NET Core. And then we have Django, this is a Python framework, and Express, this is for JavaScript. And then we have Flask, again this is for Python, and then Rails, and then we have Kova, and then we have Phoenix, right? So for different languages, we have different frameworks that we can pick up, right? So on top of Java, you can take Spring. On top of C#, you can take ASP.NET. On top of Python, you can take Django, right? So just like we have added a CSS framework on top of CSS, and we have added a JavaScript framework on top of JavaScript. So here too, after a backend language like a Java, or C# or Python, on top of it, we need to add one framework as well, right? So Java along with Spring, right? C# along with .NET, Python along with Django, right? Right. So I think that's it about the front end and back end technologies, right? So primarily it is about languages and frameworks, right? And apart from, and after this, the databases, right? So what type of databases are we going to use, right? So there are two categories. One is the traditional relation databases, and then we have NoSQL databases as well, right? So we need to know about both. We need to have proficient uh, in working with both relational database and then NoSQL database as well, right? So if you are a traditional database developer, I mean, most of the traditional database developer will be having experience majorly on RDBMS, RDBMS. Majorly, you'll be working on Oracle or MySQL, right? But as a full stack developer, right? So we should be having, you should be have that proficiency of working with both RDBMS and NoSQL, right? So RDBMS will be more suitable for uh, the traditional data where we structure the data and manage it. But most of the modern data that we are having, it cannot be structured, so they are mostly unstructured, right? So the data, most of the data is about the user generated data, right? So like the tweets that are tweeted by the Twitter users, the Instagram posts, all the online social media data, right? All the data, most of the data here, they are user generated. You can't you can't certainly put a structure to it, right? So you need to handle it uh, even without a proper structure, right? And that is where these NoSQL databases will help in managing those unstructured data as well, right? So there are different RDBMS, and then we have different NoSQL databases. So we need to have proficiency in any one of these RDBMS, in any one RDBMS, and then any one NoSQL database, right? Of course, based on the demand. So we should also be able to pick up any of the databases, right? So that is the primary uh, you know that is going to be the primary key factor for a full stack developer, right? So whatever the problem requires, you should be open to pick up the relevant knowledge and technology, right? So for instance, the project that I'm going to work with, that requires me to learn a key value database, right? I should be able to pick up that, right? So these are the different RDBMS, and then these are the different NoSQL databases. Like we have something called Redis, uh, we have Neo4j. It is a type of graph database. So we have MongoDB. It's a type of document oriented, and then we have Cassandra, HBase, all these databases, right? So we can start with any one relation database, and then we can start with any one NoSQL databases, and then going forward, we should also be open to getting to work with any databases depending upon what our problem requires, right? Right. So now I think we have covered most of the tools and technologies. I mean tools, right? So we saw different languages, and then we saw different frameworks. Uh, Now we have to move to apart from languages and frameworks, there are also different tools and best practices that one should get proficiency in order to become full stack, right? So the first thing is something called source code management, right? In fact, here it says version control. Version control is one of the process involved in source code management, right? So as a developer, we'll be having the project. So project is a one that is going to contain all the code. So it will be having different files. It will be having different folders, and each file will be having uh, you know uh, multiple lines of codes. And in a particular project, there will be multiple people working in it, right? Multiple people involved in it, right? So for instance, there will be 4 or 5 developers who will be contributing code to that project, right? And so that project has to be tested, right? So tester needs to have access to the project, right? So basically, we will be having the project, and there will be in that project there will be multiple changes that will be happening, and then multiple people has to be collaborated in that project. So how you manage this? So this forms is source code management, right? So source code management is the primary thing. Apart from developing, source code management is the primary management thing that one should know to be a full stack developer, right? So how will you manage the changes, right? So how will you collaborate between the changes made by multiple developers, right? So there's a single project, multiple developers might need to add code to that project. So how will you do that code integration, right, without affecting the work of one another? That forms the source code management, right? And version control is one of the process that involves in source code management, right? Right. So how will you do it? So we won't be able to do it manually, right? I won't be able to track the changes. I won't be able to track. I won't be able to collaborate multiple developers or multiple peoples without the help of a tool, right? And this is where we have different version control systems available, right? And one widely used and a modern tool is called Git, right? So for a full stack developer, getting to work with one of the version control system is very important. And currently, Git is the de facto version control system used by all the developers across all the uh, fields, right? Across all the company, right? So with Git, what we can do? We can do versioning, we can do merging, branching, and then distributed, right? So basically, with Git, we will be able to manage our project, right? Project that comprises our source code, right? Right. So apart from languages and frameworks, the first thing that a full stack developer must have the proficiency is Git, right? Right. And apart from Git, in order to uh, right, so in order to complement the source code management, what we are having is different Git hosting sites, right? So meaning we are not alone. Git is not alone. In order to make our life easy with respect to source code management, there are different Git hosting sites that we can use, right? So meaning, see, when we say collaboration, there is a single project. How will you make multiple persons to collaborate in the project if the project is going to be in my local, right? So it has to be there in a centralized location where everyone can access it, right? So only if it is in a centralized location, multiple people can get to access it, and then you can get to collaborate it, right? So how will you do that? So we need a centralized location, and that is where these Git hosting sites will be helpful, right? So right from providing centralized uh, platform, it also provides different security aspects. It also provides different roles for different people who will be involved in the project, right? So it will provide different automation tools to shift our code, and it also provide different integrated tools that will allow us to that will allow us to manage the project, right? So all these things will be provided by the Git hosting sites, right? So some of the Git hosting sites, uh, uh, if I have to name, so we can have GitHub, right? So GitHub is widely used Git hosting sites, so where you can create your project and manage your project in GitHub itself, right? Or GitLab, and then we have Bitbucket, right? So these are some of the Git hosting sites that we can use, right? So on top of Git, it is also important for us to be proficient in getting to work with one of these Git hosting sites like GitHub or GitLab or Bitbucket, right? Right. And then comes, after source code management, and then comes managing the uh, you know the build process of our project, right? So meaning, if I am having a project, so what I need to do, I need to compile the project, right? I need to run the test cases, so I need to manage the dependencies. So what does that mean? If I'm working in a complex application, so I don't need to write all my code, right? So some of the code I can integrate from other libraries, right? So meaning, I'll be integrating my application, I'll be building my application by integrating it with existing library as well. So this library will forms the dependency for my application, right? So my application is going to have multiple dependency. What does it mean? I need to manage the version of this dependency as well, and then I also need to have a formal structure for my application, right? So I can't create files and folders just like that. So depending upon the type of application that I'm building, so I should follow a standard template, right? So I can't have all single files in the root directory itself. So how will I organize my files, right? So whether I have to create multiple folders, or how do I do it? What is the specification for me to create multiple folders, right? Or whatever code that I'm going to write, is it going to be uh, you know is there any specification for me to write code itself, right? So these are the things will be managed by the build tools. So build tools primarily give you the template, meaning you don't need to uh, you know uh, create a structure, give a project structure by yourself. So these build tools will primarily give you a template that we can use to start a project, right? On top of it, it will be easy for you to manage the different libraries that you are going to use in our applications. And apart from it, it will also manage us by automating the build process, and then automating the testing process, and finally it will also automate the deployment process also as well. So right from start to end, whatever that we require in for me to start a project, and then for me to manage it uh, on a lifelong aspect, so this build tool will be helpful, right? So primary, there are two widely used build tools that are there. One is Maven, and then the other one is Gradle, right? So Maven and Gradle are more or likely having equal share among the developers and companies. So there are equal competitors. So we can explore by starting with any one of the build tool. Maybe we can start with Maven and we can work with it, and then um, if you want to explore more, then we can also pick up Gradle as well, right? Right. Right. So that concludes the tools and different tools, languages, and frameworks that forms the FST skill. And now we need to move to different. So we saw the primary architecture, right? So now what kind of architecture we are going to have in order to develop the application, right? So all these things is what's going to follow in this master class, right? So the one that you saw in the first diagram is more or less like this, right? So we have a UI that forms the front end. We have the data stored in database, right? And then we have the backend functionality that forms the backend. So this is the one of the primary architecture for a simple application, right? But for a complex applications, big applications, we call the big application as enterprise applications. So it will be having different subdomains, right? So for instance, if you take a e-commerce site like Amazon, for example, it is not just a simple application. It is a complex applications, right? It is an enterprise application. Reason being, it has different subdomain to handle, right? So there are different users who is accessing the Amazon. So it has to manage the users, right? So user authentication is there, right? And then there are different products that are listed in Amazon. So it has to manage the product, right? And then there are different people placing orders in Amazon. So it has to manage the transactions. And then things are getting delivered to the user's end. And so you have a subdomain where it has to manage all these deliveries. It has to track the order, track the delivery. So you have different set of functionalities, right? So how will you get to develop this? How will you give a architecture for such a complex applications, right? And that is where we have a much more sophisticated architecture called microservice architecture, right? So monolithic architecture is building an application as a single unit, whereas microservice architecture is building our application as a multiple set of small applications, and then we need to make these small applications to speak themselves in order to get the functionality as a application that is built as a single unit, right? So how will you call the application that is built as a single unit with a primary architecture is what we call as monolithic architecture, right? So as a full stack developer, we should have the proficiency with both monolithic and microservice architecture, right? Meaning microservice architecture is not the solution for all the problem, right? So there are cases where monolithic will be more suitable than the microservice. So we should have that knowledge of how to choose between monolithic and microservice, right? So basically, if the problem is complex and if the application is bigger, right, so it has to be uh, you know it has to be split into multiple applications, right? So microservice architecture is about splitting our application into multiple small applications, and thereby we getting the functionality as such of a monolithic application, right? So the only reason why we are doing this is because we have various sub features of the applications. We can't put all the features as a single unit, and then I also need to manage my resources as well, right? So how will I manage the resources? Now, if it is a microservice architecture, it will be easy for me to manage my resource, right? So I can depute like 2 or 3 developers to work in this feature, and parallelly I can depute other set of developers to work on this feature. So that will not be the case with the monolithic, right? So for managing the resource as well, microservice architecture would be a best option, right? Right. So speaking of making multiple small applications to speak with each other, so how will I make it? How will I make it possible? So meaning I want to how will I build a complex application? Basically, I'll orchestrate a complex application by integrating multiple small applications. So I need to make one application to speak with another application, and that is how I orchestrate a complex application. So how will I make one application to speak with another application, right? So that is where we use something called APIs, right? API stands for application programming interface. So that is how we get to integrate one application with another application, right? So it is important for us to understand APIs and develop APIs, or to work with APIs, right? And one of the primary standard that is there to develop the APIs is what we call REST, right? So we should be able to develop REST APIs, right? So REST basically provides the principles, the design principles, right? So we have different set of APIs that are available there, but not all APIs are REST APIs. So REST is just a principle, right? So why REST is important? So REST primarily, the primary objective of REST is to use the fundamental things available in the internet to make the application, to integrate the applications. So REST is not about following a new architecture, introducing, inventing something new. So REST is primarily about how I can use my existing network infrastructures to make the applications to speak with each other, right? So, so primarily it is about how we are going to evolve the web, right? So initially when web was introduced, it is not used for the enterprise purposes. It was used majorly for the, you know, sharing the content. It is only about sharing content. But nowadays, if you can see, we are using web more than for sharing the content, right? So all these things are managed in the web. So the entire company organization is run via web, right? So all our applications, our the HR applications, our banking system, entirely all the things are running in the web. So web now has become the de facto platform for all the organizations, right? And how this is done is because of REST, right? Right. Right. So and there is something called polyglot programming, right? So we have different aspect of the applications, software applications, and how will I choose my programming? Whether I'm going to use a single programming for my entire application, or is there is any way I can use different set of programming for developing application, right? And that forms the polyglot programming, right? So now it is possible to use different languages to create a single application, right? So now we are speaking about microservice architecture, right? So in microservice architecture, it is about building some small applications. So instead of building the entire application as a single unit, we are creating multiple small applications, and then we are going to make them speak with each other to bring in that, yeah, that functionality. So now when I say multiple small applications, these small applications can be created by individual programs, by individual language. For instance, I can create microservice 1 with Java. I can create microservice 2 with C sharp. I can create microservice 3 with Python. This is something called polyglot programming, right? So as a full stack developer, we also need to have the proficient of polyglot programming as well, right? Right. And there is something called single page applications. So all the modern web applications that we are using, they are called single page applications, right? So this is how it works: traditional page life cycle and then SPA life cycle, right? Uh, whenever, so in the web, whenever you send a request, what I expect is an HTML page. So basically, these HTML pages built in the server itself. So this is a traditional model, but over the period, one thing that is improved uh, is the client side infrastructure, right? So now the kind of machine that we are having in the client end is equivalent to the server that used to exist some decades back, right? So if you take before 10 or 15 years, we used to have servers that is running in 8 GB of RAM. But right now I'm having a laptop that is using a 16 GB of RAM, right? So one thing that is majorly improved is the client side infrastructure. So how you make use of the client side infrastructure, that forms the backbone of single page applications, right? So here what we are doing, we are taking some load out of server, and then we are putting it on the client end. So now this reduces the traffic, this reduces the server. So now the server can serve more people, right? Now the server can be more efficient, right? So how we are doing it, we are using a model, we are using an approach called single page applications, where some of the tasks, right, some of the server tasks, majorly the concerns related to the UI, right? Those concerns related to UI, that will be shifted to the client, right? So now we can see here in this diagram, not every request will produce a HTML. So every request is returning an HTML in a traditional page life cycle. Whereas here in single page application, not every request is giving you HTML. So what that mean? The required UI can be compiled and built in the client side itself. And how it is done? So basically, the application will transfer some code to our client side itself. So that code will run in our client end in order to make the applications to behave just like a traditional application, right? So apart from polyglot programming, the next big thing is single page application. As a front end developer, we should be able to create single page applications, and that is where we use this JavaScript framework. Primarily, this Angular, React, Vue, whatever that we are seeing, they will be helpful to create the single page applications, right? Right. And then finally, there is something called serverless architecture. So meaning now this is a world of cloud, right? So most of the things that we are using, they are from cloud, right? So meaning we are not storing all of our data in our local, right? So we are not accessing all the applications in our local, so we are majorly using the browsers, right? So all the computing infrastructures now are provided by cloud, right from storage, right from compute environment, right from uh, other features, right? Most of the features, they are now provided by cloud itself. So how you can leverage the cloud features to build my application, right? So that forms the serverless architecture. So serverless architecture here is primarily is about developing the functionality, and how we are going to deploy the function, on what platform the function is going to run, how someone is going to send request to the function, meaning how the function is going to get invoked. All these things will be taken care of cloud, right? So on top of, apart from microservice architecture, there is something called serverless architecture, right? Meaning how you are using the current cloud infrastructure to develop and manage our applications, right? And as a full stack developer, it is also important to work with the different you know development features or the environment provided by cloud, right? So we have different tools, different cloud providers providing the serverless features, right? So we have something called AWS Lambda, right, to start with, that is leading the way. And then we have Kinway, right, IBM, Google Cloud Functions, right? Right. Right. So then comes the deployment methodology, how you are going to deploy your applications, whether you are going to have a single release or multiple release. So single release is the traditional approach, right? And releasing our application in multiple release is a newer approach, something called agile methodology, right? So agile applies to all the fields, and it is also primarily, it can also be primarily applied to software development uh, and deployment, right? So as a full stack developer, it is important to work with, it is important to understand the agile methodology, and then it is also important to use different agile tools as well, right? Right. So one agile tool that I know as a full stack developer that we need to get proficient is Scrum, right? So agile primarily is about principles, right? It is about how we communicate, what are the different meetings that we are going to have, right? What is going to be the periodicity of that meetings, right? What are the different rules, what are the different peoples that are going to involved in the project, right? Primarily agile will give you the principles, right? And how you can use the principles, I mean, it is not going to mandate anything. How you get to implement it, how will you follow agile in your work, and that is where these agile tools will help out. So we can use Scrum, or we can even have something called Kanban that we can follow, right? Right. So like agile, like we used agile for agile approach for development and deployment, we can also use agile for testing as well, right? So we have something called test driven development, acceptance test driven development, and then we have behavior driven development, right? So these are some of the things that we need to pick up if I have to be a full stack developer, right? So meaning, I know in a traditional approach, test follows the development, right? So first development will happen and then test will development. So agile is about, we need to test in the earlier stages of the development itself. So as the development happens, test should happen, right? So test is something not that will happen at the end, right? So test should run parallel with the development, right? So the yearly you test the application, it is going to prevent the testing cost, right? So the more later you find a bug in your application, it is going to be more difficult to fix that bug. If the same bug is uh, you know uh, uh, identified and prevented in the initial development stages, then it would be easy for you to fix that, right? So we have something called bug containment, right? So that is the primary focus of the agile testing as well, right? So as part of agile testing, we need to have something called test driven development. We have PD development, so we need to have proficient in doing all these things, right? And again, right, so we are actually seeing different tools, technology, frameworks, libraries. So how will you get to learn this? So like I mentioned, you have official sites there for all these things. So now to get started with it, we can use the documentation provided in the official site itself, right? Right. So we should be able to do all testing. So we should be able to do functional testing, non-functional testing, right? Maintenance, right? And so how are we going to integrate? Like when we were discussing about Git, we were speaking about source code management. We were discussing something about how you get to collaborate different peoples in a project. So meaning different people will add code to our project. So how will you manage? How will you add the code to the existing code base? So we'll be having a single code base, and then multiple people will add code to the code base, right? So how the code has to be added to that code base, whether on daily basis or whether one after another, how it will happen, right? So this is called this is called something. This is something called code integration. And how will you solve the code integration problem in the modern days is something called continuous integration, right? Right. So continuous integration is about whenever when some code is getting added to the code base, that code has to be validated, right? So it is about how we are executing the test cases, right? So like I mentioned, now test is not something that will happen at the end. Test will happen in parallel to development, and in that development there are different types of testing that will happen. So we will be having unit test cases, we will be having end-to-end test cases. There are different types of tests that will happen in different test stages. So how the test has to get executed, right? So whenever there is a new code that is getting added to the code base, these test cases should get triggered, right? And that forms the continuous integration, right? So only if the test case runs and passed, only then the code that you have added to the code base will become valid, or otherwise it will become invalid. So if it is invalid, how it is getting communicated, right? So there will be different people associated with the project. So you need to send information, you need to send communications to all the people associated with it, right? And that is forms the continuous integration, right? So this cannot be done manually, right? So meaning when a project fails, we can't manually depute someone to monitor the thing, right? And then we can't expect him to manually put a message to others depending upon how the project build went. So this has to be automated, right? So how will you get to implement continuous integration? And that is where we have different CI/CD tools, right? So we have something called Jenkins, we have Circle CI, right? And we have these cloud providers also providing their own set of CI/CD tools that we can use, right? And like I mentioned, the Git hosting sites previously, that will also offer different CI/CD features that we can use. For instance, we have GitLab that provides um, you know uh, CI/CD, right? Right. And then we have something called Bitbucket, Jira, right? So these are the different CI/CD tools. And again, we don't need to work with all these things. We should be able to work with to start with. You should be able to have one tool. For instance, in case if you are using GitHub or GitLab, you can use GitHub Actions, right? Or you can use GitLab CI, right? So GitLab CI is the integrated CI/CD tool, and then GitHub Actions are the integrated CI/CD tools, right? And then we can explore one by one, right? uh, so Daniel, both CI/CD and Agile complement each other. In fact, CI/CD complements Agile, right? So even Agile is also more dynamic and never ending, right? So with Agile, we don't exactly have a final sprint, right? So CACD is a kind of is a kind of complement what we are trying to do with Agile, right? So every major release, uh, right? So every sprint, in every sprint, we'll be having a CACD running in parallel, right? So how will you manage a particular sprint, and then there, how will you automate things that are happening in a single sprint? How will you automate things that are happening in a single sprint? And that is where we use CACD. So CACD actually complements Agile, every cycle of Agile. Yes. Yeah. Right. See, we are saying in single sprint we are integrating codes developed by multiple developers. So we are deploying it, right? So what is the result of a particular sprint? It is going to be a product, right? Not the entire product, but some features of a product. It is also going to get deployed, right? So every sprint will be having that CACD. So CACD is something that run in the entire sprints. So each and every sprint will be having CACD, right? Right. And then after CACD, now here, how will you ship your software, right? So this is a traditional cargo transport that used to happen. So we have multiple items that has to be shifted, and then we have multiple transport to ship this, right? And this is a complex approach. How we are solving this? By using something called containerization. So we have a container, whatever that we want to ship, we can put it in the container. So this container can be transported via road, this can be transported via air, this can be transported via ship, right? So that is how we are solving the multiplicity. So we have various items, and then we have various mode of transport that we need to transport. So how we are solving this? We are using the container. The same thing applies to the software as well, right? So we have different environments where we need to ship our software. For instance, we have a developer environment, that is where the software is getting uh, you know that is where the software is getting born. And then after development environment, it has to be tested, it has to move to a testing environment or a stage environment, and then it has to be installed in the user environment, right? And then that is a user environment, right? So we need to ship our software to multiple environment, right? So the problem is, the software that is running in my machine might not be running in my tester machine, might not be running in the client machine, because right, so he will be having the necessary environment, but he might be having different versions of environment, right? Different versions of the tools that is required to run the software. So how will you manage these versions primarily in multiple environments? And that is where we use something called containerization. So instead of shipping our applications as it is, we put our application inside a sandbox, an isolated environment, and then we ship that environment itself, right? So we have our software. Instead of shipping our software, we are putting the software inside a isolated environment. This isolated environment is called as container, and then we'll ship the container. So it is called the software container, right? So as a full stack developer, it is also important to understand and to work with this, to work with containerization as well, right? So what are the tools available for containerization? So we have something called Docker, right? So Docker is a containerization tool. This will allow us to containerize and containerize our software and to ship our software, right? Right. So we started with, so basically FSD skill is about developing, testing, deploying, so all those things. And even when it comes to developing, what are the different architectures that are there? Monolithic, microservice, databases. So everything that forms the software development, right from writing the single code and right till the deployment, whatever aspects are there, that forms the FSD skills, right? So we saw a glimpse of languages, we saw the glimpse of tools, we saw the glimpses of frameworks, and then we saw the glimpses of some of the best practices. We saw SCM, we saw the process like CACD, and then we also saw how it is getting deployed. So as a full stack developer, one should get proficiency in all these things, right? So this is a path, right? So what is the career opportunity? What is the age that we will be having if we acquire full stack, right? So now this is a stat that I'm having, right? A small stat that help us understand the demand of full stack, right? So now the business owner are expecting people to be full stack. Reason being, full stack developer can perform much better than a normal backend and front end, right? So there is a 30% increase since 2015. So this is as per LinkedIn for full stack developers, and this number will grow higher by 2024 and going forward, right? And I have a small stat on the salary as well, right at the bottom, right? So so basic primarily a full stack developer will get around 110,000 per year according to the survey, right? So there is a demand for always, I mean, business owners are expecting people to be full stack. So if you are a full stack developer, and we will be having a slight edge over or more edge over the people who is just back end or just database or just front end, right? Right. So you can typically work with different industries. So meaning there are applications belong to different fields, right? So we can also get to specialize in these applications, right? So we'll be able to work with healthcare applications, finance. So when it comes to applications, there are now the applications is running the industries. E-commerce is running by industries. I mean, e-commerce industry is running by its own applications. Healthcare is having their own applications. So as a full stack developer, we can get into any of this specialization, right? So what are the roles? You can take a full stack engineer. You can replace a front end developer. You can replace a back end developer. You can be a DevOps engineer, right? Since now you will be knowing CI/CD, SCM, Docker. You will be a DevOps engineer. You will also become a mobile developer, and then since you know more about testing, now you can also be performing as a QA as well, right? So you can open to any developer, right? So that is not the case with the front end, right? So front end developer will always suitable to a front end role, right? But that is not the case to a full stack, right? So now the window is open, right? Now we have multiple windows to get into an IT field, right? Now if you are a full stack, uh, we will be having front end roles, back end roles, depending upon our interest, and uh, you know depending upon our interest, we can get into any of these roles, right? Yeah. Right. So that's it from me, guys. I hope this session would be helpful for you to know the glimpse of what forms the FST skills, right? So thanks for joining the session, and